Horizontal deflection, second problem, or that is sixth problem or whatever it is, in continuation, find horizontal deflection at not free end, at roller end, at roller end of the ray, shown in figure by Castigliano theorem and unit load method. So you can take this example. Again, determinate frame. It has to be like this only, it cannot be anything. Either it has to be cantilever type in the previous example or simply supported beam type. No other thing. So this is one load, 20 kilonewton per meter. That is what I have taken to start with. A, B, C, D. This is 3 meters, 4 meters.
6 meters.
4 meters. So he needs one more load to be taken. We take a horizontal load, say 10 kilometers. That also it is 10 kilometers load. So we will take that, just slight modification of it. So with this, all this set is over. I take it out. This is the last example in this strain energy application of strain energy method, that is Castigliano's and unit load methods. So first we will take up Castigliano's theorem using Castigliano's theorem. So as usual, write up the equation. So we have H dr delta H at D delta D, horizontal deflection. I can use the same symbol delta, deformation. Even rotation also I can use that, either theta or delta itself. There is no rule as such, which symbol you have to use. So delta D is equal to, it is sigma because it is basically a flexural member. It is mx, delta mx by delta q dx divided by L, where q is equal to load applied. You have to apply a load to find the deformation, whether it is horizontal, vertical or rotation. Rotation also you can call it as Q, but it has to be a moment, that's all. So Q is the load applied at D in horizontal direction. In horizontal direction. Because horizontal deflection is the one which is required. So that is like this. This is load applied. This is one load given, 23 Newton per meter. Another load also I have taken 10 kilometers. It doesn't matter. It can act either here or somewhere in between. It doesn't make any difference. A, B, C, D. And of course, EI is constant. And or it can be varied also. 2EI, 2EI, anything. So correspondingly, carefully you have to take that EI. In the table anyway, you are giving that EI one more column, their appropriate value, you write it. So here, reaction, here, only you will get horizontal reaction. So both horizontal loads are acting from left to right. So here it has to be
left,
right to left.
right to left.
So 10 plus Q. So this reaction by sigma H equals 0, this HA will be equal to 10 plus Q. Then you can find out what is this vertical reaction. Carefully you have to do. You take moment about J. So this vertical reaction, VD, you have to take moment about A. If you take moment about A, then you will get VD into 4 VD, which is in the anti-clockwise direction, 4 VD. So these are all clockwise, so that is equal to. So here due to this, it is 10 into this side 4. 10 into 4,
40.
I'll write it. It is clockwise. Then 20 into 4 into
2.
4 by 2, that is 80 into 2, 160. 160. Then here it is Q into, because this is 3 meters. So it is acting
1
as
meter.
Q. So another 1 meter. So it is plus
Q.
This you have to do it correctly. So this will be 40 plus 160, that is 200 plus Q.
Divided by 4.
Therefore, VD equals, this is Q by 4 plus 50. This is your VD. Then we can adopt sigma V equals 0. So VA plus VD, both you can take it in that direction. VA plus VD is equal to 20 into 4. That's the only
80.
load you have that is acting down. So you can take it here, 20 into 4, 80. So here VD is this. Therefore, VA equals, this is 80 minus VD, that is equal to 80 minus Q by 4 minus 50, that is 30 minus
Q
by 4. So VA equals 30 minus Q by 4. So this is 30 minus Q by 4. Here this is 50 plus
Q by 4.
Q by 4. That will be is correct reaction. So is a 50 load. So then we can prepare the table. How many sections you need?
3.
To take? Here I need 1 section for this member 3D. I will measure the distance from D at a distance A. Then I need another section X2. Safe, I will measure the distance either from C or D. Both are safe because both lie in one vertical line. So I will measure the distance either from C or D there. Another section X3, I will measure the distance from D. These 3 sections are enough because moment about these 3 sections will remain same in that length of the member CD, CB, AB. There is no other intermediate load causing, adding to the moment at the section. So 3 sections enough. So you prepare the table. So say segment, 3 segments. This table you have to prepare correctly without any mistakes. So 3 segments, CD, then CB, AB. And origin for CD, we are taking C as the origin, or not D as the origin. For CB,
C.
either D or
C.
You can take it, either one, both are same for measuring the distance. And for AB, I will take A as the origin. Then limits, integration, limits. For D, it is for DC
0 to 3.
0 to 3.
0 to
For
4.
CB 0 to 4.
0 to 4.
0 to 4. Because this is 4 meters, 4 meters, 3 meters. That you have to take right. Then you have to write MX about the sections. Whatever. For MX, for this MX1, that is due to this, it is QX. QX is like this, sagging inside the frame, so it is positive. So it is qx, and this will not give any moment about that because it is passing through that. So it is only qx. Right? Same thing here. In this member here we will write, this will not give any moment, only this will give moment. It is again sagging within the frame. Inside the frame, it is sagging, so positive. It is 10 plus q into 10 plus q into x. Then, in this middle member, carefully you have to see this sagging, because this q, it will give a moment, again inside sagging, that is q into
3q.
This height 3q, it is 3q. Then due to this Vd into x, that is 50 plus q by 4 plus, that is 3q plus 50 plus q by 4 into x, that is 50x plus qx by 4 plus 50x. Correct?
20 into x into x by 2.
And this 20 into x into x by 2, that is 20x squared by 2, that is 10x squared, that is hogging moment
minus 10x squared.
That is, I have to take 10x squared minus, because that is hogging outside. So this is our mx for all the 3 sections or 3 segments. This carefully have to find very happy. Then I need delta mx by delta q. Only partially we have to differentiate with respect to q. Here
x.
It is x. Here also it is x. Because 10x
0.
partially differentiate, it will be 0. Only this qx means it is x. Here 3 plus x by 4. These two will not give any derivative because they are treated as constant. We have to differentiate partially only with respect to q. So only q's only have to take, rest are all 0. So this will be 3
plus q by 4.
X by 4. 3 plus
x
by 4. Now, EI value, EI is constant, we take that. If it is varied, so because that particular thing, only because of this 10 you are getting. Otherwise, if it is not there, that also get this and this will be same. Now, you therefore, from 1, you call this as 1. So, from 1, you integrate. So, 1 over EI, you will take it outside. 3 members having 0 to 3. First, it is mx delta mx by q.
qx square.
qx square. 2x square dx plus 0 to 4. Here, this into this. I will write that. I will add these two. Or as it is, I will write it. Okay. 3q plus qx by 4. Then plus 50x minus mx square. That is your mx into 3 plus x by 4. That is delta mx by delta q into dx. Then plus 0 to 4. This 10 plus q into x plus
qx square plus
into
10x.
x. That is 10x plus qx square. Qx square plus 10x dx. Now I will put q equals 0, as I told you. I will substitute here itself so that integration things will become simpler. So this will cancel. Here this will go. Here this will go. This will go. If I put q is equal to 0. If that value is there, means put that value and simplify further so that there won't be any confusion or doubt or mistake you will commit in the integration. So therefore this is equal to, that is, this will not, I need not write here now. Here only this I will write. Right? Integral 0 to 4.
50
it is 50x minus 10x square into, this is 3 plus x by 4 dx. There plus 0 to 4, it is 10x
dx.
dx. There won't be any mistake if you do like this. Substitute q. The moment you find out this, then you put the value of q. You will 0 or whatever value. There won't be any mistake. So that is 1 over di. This we can simplify now. 50 into 3, 150x. Then 50x into x by 4, that is 12.5 x square. Right? This I multiply.
Yes, sir.
Then this is minus 30
x square.
x square. Then this is minus 10 2.5
x cube.
x cube dx. Then here plus integral 0 to, of course, here 0 to 4, 0 to 4 nx dx. I am indicating all these steps so that there won't be any confusion or mistake in our integration work. So here I will take now first x cube, that is minus 2.5 divided by 4, this is x4. Integral x cube dx is x4 by 4, that 4 I will take it outside, so limits 4 to 0. Next,
minus 17.5.
this is 12.5 x square, 30 x square, I will add it, I will
Minus
get
17.5.
this
Minus 17.5.
17.5, so that is minus 17.5 into integral x square dx is x cube by 3, that is x cube, limits 4 to 0. That is 150 into
75
x squared by 2, or that is 150 by 2 means it is 75 x square, limits 4 to 0. So this is done. Then this is 10x squared by 2, that is 5 plus 5x square, limits 4 to 0. Both have been plug. Now you substitute. That's all. It's only question of integration.
Minus 1600.
Huh?
First one, minus 1600.
First one. 4 to the power of 4 divided by 4.
4 into
that is 4 cube. 4 cube means 64. 64 into minus 2.5. That is 160. Right? Do it and check.
Yes, sir. 160 by 4.
Okay, now here.
So that is 40, sir. 160 divided by 4.
See, this is 4 to the power of 4 divided by 4. That is 4 cube.
Yes, sir.
4 cube means 64. 64 into 2.5.
160.
Right? You should not do mistake.
Yes, sir. Yes,
It
sir.
has happened earlier. I just took it. It got it gave me result, wrong result.
Yes, sir.
So that mistake you should not do. And then here,
4 cube.
this is 4 to cube.
64.
64
Into
64 into
5.
17.5 divided by 3.
10.5 divided by 3.
Correctly do it.
373.3.
70?
373.
373.3,
3.3.
yeah?
Yes, sir.
Okay. Then here it is 4 square, 16 into 75.
1200.
Huh?
1200.
1200. Here it is 16 into 5, 80.
80.
We can simplify this. 1280 minus 373.3 minus 160.
746.7.
746.7 divided by divide. Therefore, your delta D is equal to, it is positive, so that means assumed direction is okay. That's all. If it is negative, we will get opposite. Otherwise, with negative matrix. This is about Castigliano's theorem, solving this problem or for finding the horizontal. Whatever may be loading, whatever may be here, same procedure, whether it is an equal leg, all similar. Now we will solve the same problem by unit load method, so that completes this application of strain energy. So we will take up next. Unit load method. B, unit load method. So, as usual, write the equation delta D. Here it is instead of delta mx by delta q, you have mmx dx by y. That's all the change. Then, where mx is the bending moment at any section due to given loading on the frame. Like that. This is the frame. So A, B, C, D. This is that 10 kilonewton you are getting, and this is 20 kilonewton per meter. So here you will get reactions 10 kilonewtons. Earlier you had 10 plus Q because I applied Q also directly. Here I will take it separately that unit load. And here the reaction, so it is 10 into 440. Here it is 20 into 4 into 2. That is 160 plus 40. 200 divided by 4.
50.
Just check that one. And sigma V equals 0, you will get, 20 into 4, 80. 80 minus 50,
30.
30. This is what you are getting.
Moment.
Right?
Yes, sir.
No moment.
No moment. Fixity is.
There's no other this thing. These are the only reactions because it is an equal leg. That is why you are getting different reactions here. It won't be exactly half the total vertical load. So you need two sections. Yes. Another section is here. Another section. 3 sections. We take as before, and
Unit.
this is about that. Next, you have to apply a unit load because here for finding mx, this is for mx. This is for small mx at different sections. So you have to apply unit load in the direction where deflection is required. So for this, here one should get 1, sigma heat equals 0. Then V, vertical reactions. Here you see, it is simple way is, these two will be equal and opposite. They give you a moment in clockwise. Here reaction by way of reaction, we should oppose, because this has to be in equilibrium. Whatever this moment should be equal and opposite. This moment has to be like this. Fix it up. Then what is the applied moment? It is 1 into 1. 1 distance is 1. 1 into 1 is the applied moment. Here, suppose if I take this as V and V, V into 4.
V into 4.
V should be equal to 1. Therefore, V should be 1 by 4.
0.25.
Whatever it is. That's right. It's as simple as that for finding the reaction. Next, you prepare the table. So segment, 3 segments. Here again, D.
Origin.
Here are the D or C. Here J. Limits are same. Mx only will change. In this. Small mx and this will change. That you can compare due to unit load, whatever moments you are getting, that whether it is same as this. That you can compare. That law of convenience. So here now, mx, here, moment.
0.
0. Right? There is no load causing. Here,
15 to
it is 50x minus
minus
20x into x
10x
by 2,
square.
that is 10x square. This is hugging, this is sagging, so this will be 50x
minus 10x square.
50x minus 10x square. That's all. Very simple expression. Here, I will take this side. This will not give any moment.
10x.
This 10x sagging inside.
10x.
So it is 10x. That's all. Then
Small mx.
small mx. Instead of delta mx by delta q, it will be small mx. Here, this is the first section. Distance is here. Second section, distance is here. Third section, distance is here. Same as whatever you have taken. This section moment, this will not give any moment. This will be 1 into x. Again, sagging inside towards inside. Sagging.
X.
So it is positive. Earlier also in that column, you can just check delta mx by delta q, that was x.
Yes.
Then here it is
0.25. 1
This.
by 4 into x.
1 by 4 into x sagging.
1 into
Then this 1
1
into
into
3. That is also sagging. So 1 into 3 is 3. This 1 by 4 into x is x by 4.
X by 4.
Just check previous column of delta mx by delta q. You should have same value. That's a check. When you do the problem, both you do together, so you will be getting confident. You will be confident by working some problems. You will never get any mistake also. Both you have to get the same solution. Here it is 1 into x. This will not give any moment, so it is just 1x. That's all. Now integrate from 1 this integration values will alter. 1 over here I have taken for all members. It is said in first member it is 0 to 4 mx. This is 0 dx. Next member again 0 to 4. This into this. I will multiply that.
150.
That is 150x into
3.
3. That is
150x.
150x. Then 50x into x by 4. That is 12.5 x square. 50 by 4 is 12.5. Then
X
x
square.
into x is x square. Then this minus 10x squared into
minus 30
minus 30
x square.
x square. That minus 30 x is right side. Otherwise they would have added. Anyway, it was right side. Minus 30 x square. Then this is minus 10 x squared into x by 4. That is minus 2.5 x cube. That's all. Into dx. That is that. This mx. Then here it is 10x square. Plus 0 to 3. 10x square dx. Okay? Now simplify. That is, this will go 1 over di. Here it is 150x into dx. That is 150 by 2 into x square. Limits 4 to 0. Then these two I will add it. So I will get 17.5 minus 17.5 into integral x squared dx is x cube by 3. That is x cube. Limits 4 to 0. Then minus 2.5 x4 by 4. That is x4. Limits 4 to 0. Then this plus 10 by 3 into x cube limits 3 to 0. Simplify. That is 1 over di. This is 4 square. 4 square is 16. 16 by 2 is 8. 8 into 150. 1200. Next, this is 4 cube. 64. 64 into 17.5 divided by 3.
373.3.
373.3. Minus, of course.
Yes, sir.
Then here 4 to the power of 4 by 4, it is 4 cube. 4 cube means 64. 64 into minus 2.5.
160.
160. Here it is 3 cube. Divided by 3, it is 9. 9 into 10, 90. Previous case we did some mistake, I think, while substituting. And we have
that is 4 cube. 4 cube into 10 divided by 3. Last one.
This.
Sir. 10.
This is 3 cube.
3 cube, yes, sir.
Previous also you check once. There also integration limits are 0 to 3. We have, I think it was cancelling, I think, anyway.
1200.
So this we can simplify, see whether you are getting
3 minus 160 plus 90. 756.
7?
75.
Just check.
Just 10.
Small, you check where it has gone.
Yes. I think we made it, sir. Yes, sir.
Right, our previous one you check.
750.
This last integration problem.
Maybe 756.7.
That is,
yes, sir. 756.7.
Right?
Yes, sir.
0 to 4.
73.3.
I think this is 0 to 4.
0 to 4. Yes, sir.
First one get cancelled.
First one get cancelled, sir. That is 0 to 4, sir.
This is 0 to
now it will correct.
4. This is
0 to 4.
This
4 cube.
4 cube.
64.
640 by 3.
By 3.
213.3. Now you simplify.
213.3 minus 160 minus 373.3 plus 1200. Yes.
You are getting. You have to get wherever you go. Absolutely, it's no problem. Whatever may be the problem. We have completed beam and trusses, rigid, plane field.
Yes.
So with this strain energy method over. One simple example, just how to find total strain energy stored and how to equate the total strain energy to external work done. From that, how to find delta. They are very simple examples that will do it. That is, actually if they ask only by strain energy, then limitation is only one load should be there. One load, one deflection. If that is the only thing asked, no other load. We cannot have multiple load and all those things. It is only one load. UDL also not possible. Either one moment and find the slope. And one vertical load, find vertical deflection. So vertical load and slope, you cannot do it. Similarly, moment and vertical deflection, you cannot do it. The cross verification, cross determination will not be possible in strain energy. Whereas this is generalized procedure, you can do anything, either slope or deflection or any type of load, generalized procedure. But by strain energy, that is just simple application of calculation of external work load done to internal work done, that is strain energy.
So that is x power 4 by 4, sir.
Huh?
10 by 3, that is x power 4 by 4, 10 by 4.
Okay.
Now it will become 64
Whatever it
into
is.
10.
Anyway, this value as long as you are
160, now 160, sir. 160 plus and minus cancels, this will become 746.
Okay. So it is matching it.
Yes, sir.
That's all. Just do it. That's all very simple.
Yes,
You
sir.
verify it. If you are not getting, just approach me. I will do it
Yes.
again
Yes,
and
sir.
show you the calculation.
Yes.
Right? So
Okay.
last procedure, just one simple application of strain energy. That's all. How to equate.